Let's write down integral here and start. Let's start first by drawing a coordinate system. So this is our coordinate system. Let's call this is x and this is y. And let's draw a function here. And the function, let's call the function is fx. And let's get a projection in at x, and let's call it xm. And another projection, let's call it x0. We will try to find this area under this function fx and limit it by x0 and xm. So let's erase this written part, because we are going to use this area to understand how we can go to integral from a simple calculation. So since we have a curve as fx, we cannot maybe calculate easily the area under fx, but let's divide the x line under this fx to equal parts. We divided it to 5 parts. Those are equivalent. All the parts in x called dx. And let's get a rectangular for all those dx's. So we cannot calculate by a formulation because we have a curve as fx. But if we divide the area by those rectangulars, and let's call all those points, let's use another color, black again. This is f1, this point is f2, this point is f3, this point is f4, and this point is f5. So we have 5 rectangles. And let's draw to show better the areas. So this is the first area, let's call it A1, and this is area 2, 3, 4, 5, and total of let's talk about area first one, A1. It is, the length is f1 and the bottom line is dx, so area is f1 multiplied by dx. And area 2, it is f2 multiplied by dx, right? So then the total area is, how we can write the total area then? Of course it is the summation of all those areas. But yeah, also let's write them openly. f1 multiplied by dx, area 1, f2 multiplied by dx, area 2, f3 dx plus f4 dx plus f5 dx. So but what is there? So we calculated in this with this simple method, but what error we have? Those are our errors. We couldn't calculate those parts. This is our error. And the question now is how we can make this error goes to 0. Yes, as you guessed, delta x need to be 0, or let's say we have number of those rectangulars that goes to infinity. Then how more we have, that much we are close to real area, right? So we can say delta x goes to 0 or n goes to infinity, and that brings us to limit. So we can write, then we can write the area equal to limit. Now delta x need to go to 0, right? That means we have infinite number of those rectangles. But let's say on the upper side, to understand better, we can define this by a summation, right? We have 5 rectangles. Let's write down it in a summation. E equal 1 to E equal 5 fi multiplied by dx. So this is a summation. So we're gonna write it with infinite number of rectangles. So it is summation of from E equal 1 to E equal n. What we're gonna write here, fix multiplied by dx. Already this is definition of the integral. So it is from x equal x0 to x equal xm fx dx. So this is why integral gives you an area. So let's have an example. Let's use this integral formulation on example. Let's calculate the area of a rectangle. Draw a coordinate system again. Okay, let's draw it here. Let's use this. This is x. This is our fx. And let's draw a line here. This function is a constant. Okay, let's call it fx again, but this is a constant because we will have a rectangular. Let's say it is a, so that point is a, and let's get a projection again on x, and let's call it xm. And here are 0 point. So let's use the integral to calculate this area. But we know that area we will find should be a multiplied by xm. Let's try to find it by integral equation. So area is equal to from x equals 0 to x equal xm. And function we have, let's call it fx again, fx dx, and fx equal to a, then we wrote a instead fx, a multiplied by dx. And let's take it out of the integral by x. We took dx outside of the integral from x equals 0 to x equal xm. Then area is equal to a multiplied by xm in parentheses minus x0. And then this is a equal xm. This is the area, right? So, for instance, if xm is b, then we can write it like a multiplied by b, right? The area of this rectangle. A multiplied by b. Yeah. Okay, let's try another example. A triangle. Let's try to find the area of a triangle by using integral. And let's draw a coordinate system again. So this is x, this is y, x, depending on x. So let's draw a line passing through the origin of the coordinate system. Yes, this is our functional line depending on x, So this is projection again, let's call it A, and projection on Y, let's call it H. And the function then, what's the function here? Then it is H multiplied by A multiplied by X, right? Yes. So then let's write down the area by integral equation. X equal, so this is 0, x equal x rho, so our x0 is 0, x equal x0 to x equal xm, and our xm is A. Fx dx function, so x equal x0, x equal xm. What is the fx? It is xm equal A, yes, h over A x dx. So, and if you take this outside of the integral, h multiplied by A x square, x equal xm A, x equal x0 equals 0, h over A in parentheses A square minus 0 square, right? But we should write also divide by 2, right? When x dx goes outside of the integral, it's divided by 2, so yeah, and that gives us h over A multiplied by h square over 2, and this is h multiplied by h over 2, and this is the area of a triangle. Thank you very much for listening. Please check our next videos. Thank you very much.